Alright guys, in this playlist I'm going to go through amount of substance. Now this is quite a hard chapter, so I'm going to try to go through it very slowly and in a lot of detail. I've also included a lot of questions so that we can get a lot of practice. If you guys want to get some more practice, click the link in my YouTube channel for the Google Drive, which has a lot of questions by topic, including amount of substance. If you enjoyed the video, make sure that you like and subscribe and comment down below what topic you guys want me to go through next. So the law of conservation of mass states that no atoms are lost or made during a chemical reaction, so the mass of the products equals the mass of the reactants. So essentially what this means is that over here we have 1 Mg atom and 1 Mg atom on the right, and we have 2 CO atoms on the left and 2 CO atoms on the right. So basically we should always have the same number of atoms on the left and right, and because of this our mass on the left and right should always be the same as well, or our total mass, sorry. So here, for example, we have 4 grams of magnesium and 2 grams of chlorine, and 4 plus 2 equals 6, so our total mass on the left is 6, whereas on the right side we only have one substance, okay, and it's magnesium chloride, but the total mass is 6 grams. Okay, so the total mass of the reactants is always the same as the total mass of the products. Now if there's a change in the mass when you're weighing something, it usually means that one of the reactants or products was a gas. So in this reaction that we have up here, the mass would go up because when you initially weigh the reactants, you're only weighing the mass of the solid Mg atoms, but when you weigh the products, since the whole product is a solid, you're weighing the mass of both the Mg atoms and the O atoms. So basically, here, initially, when you have the reactants, you're only weighing the solid because you can't weigh gas. However, on the right side, you're weighing both the magnesium and oxygen atoms because they're both solid. Whereas here, on the left side, you weren't weighing the oxygen because it's not a solid, it's only a gas. So you only weighed the magnesium atoms. So in this case, the mass would go up. And the opposite is true for this reaction down here. So initially, the calcium, the carbon and all the oxygen atoms were all solid. However, in the end, the carbon atom and 2 of the oxygen atoms become gas to form carbon dioxide. So because of this, the total mass would go down. Alright, so when you have 6.022 times 10 to the power of 23 particles of a substance, the weight of that substance in grams will be the same as its MR or its AR. For example, 6.022 times 10 to the power of 23 molecules of methane will weigh 16 grams. Okay, and this is because the MR of this is 16. Now, instead of always saying 6.022 times 10 to the power of 23, we can also just say 1 mole. Okay, this is a bit like saying a dozen eggs or a herd of sheep. 1 mole means 6.022 times 10 to the power of 23. So 2 moles will be 2 times 6.022 times 10 to the power of 23 particles. And we can use this formula to calculate the number of particles. So essentially what you do is your number of moles times Avogadro's constant is equal to your number of particles. Now we can also say that 1 mole of a substance is when the weight of that substance in grams is the same as the MR. So we can use this formula, mass divided by MR equals moles. And you may have seen the triangle, which looks like this. Alright, so there's a lot of questions, especially 1 markers, that involve using both of these equations together. So I'm going to go through some examples right now. Okay, so here we're asked to work out the number of atoms of tin in a 6 gram sample of tin metal. Alright, so to work out the number of particles, or the number of atoms, we need to know the number of moles and Avogadro's constant. Now, I forgot to mention this, but Avogadro's constant is that number that we kept seeing, which is 6.022 times 10 to the power of 23. Now, the number of moles we don't have yet. However, we do have the mass, and we can find the MR of tin from looking at our periodic table, and we can use that to work out the moles using this equation. So we get, alright, now that we have a number of moles, we can times this by Avogadro's constant to work out the number of atoms of tin we have. Alright, and this is the number of atoms of tin that we have. Alright, here's a 1 marker for you guys to try. Pause the video, try it yourself, and play to see the answer. Alright, so they've given us the mass, and they've also given us the MR. So we can do mass divided by MR to work out moles. And now we can do the moles times Avogadro's constant to work out the number of particles of aluminium oxide. So that we get... Alright, so this question has a bit of a twist to it. So they're actually asking us how many ions there are present. So the answer we've got right now would be correct if they asked how many molecules are present. However, if we want to work out how many ions there are, we need to work out how many ions are in each molecule. So we have 2 Al3 plus ions, and we have 3 O2 minus ions. So in each molecule, we have 5 ions, because 2 plus 3 equals 5. So now we need to times this answer by 5. Okay, so the correct answer is actually D. The reason why I didn't get 9.03 is because I rounded a bit during the working out. Okay, here's a question for you guys to try. Try figure out which reactant here is the excess reactant. Pause the video and try it. Play it to see the answer. Okay, so the answer is that this is a trick question. So suppose for a coffee you need 100 grams of milk and 20 grams of sugar. There's nothing in excess. Here you just have more milk than sugar. Excess means you have more of something than you need. 100 grams of milk and 20 grams of sugar is just the ratio to making tasty coffee. So if you were to have 200 grams of milk and 40 grams of sugar, there would still be nothing in excess because it follows the exact same ratio. However, if you were to have 100 grams of milk and 40 grams of sugar, then the sugar will be in excess because you only need 20 grams of sugar for 100 grams of milk, according to the ratio. So you have more sugar than what you need. As a result, the milk in this case is a limiting reactant. So because we have more sugar than what we need, the sugar is in excess and the milk is a limiting reactant. Now in another case, if you had 200 grams of milk and 20 grams of sugar, then the milk would be in excess, because for 20 grams of sugar you only need 100 grams of milk, so you have more milk than what you need. We can use the same thinking to see if substances are in excess using moles and the balanced equation as the ratio. Here's how to work out the excess and limiting reactants. Work out the moles of A that you have using mass divided by MR. Work out the moles of B you need using the molar ratio. Work out the moles of B that you actually have using mass divided by MR. If you have more moles of B than what you actually need, then B is in excess. If you have less moles of B than what you actually need, then B is the limiting reactant. If one substance is in excess, then the other one is the limiting reactant. So here we have 5 grams of magnesium, and it's reacted with 6 grams of oxygen to make magnesium oxide. We're asked here to work out which is the limiting reactant. Alright, so to answer this question, I like to lay everything out in a table. So I'm going to write magnesium and oxygen. And I'd like to have my mass, my MR, and my moles. I'm also going to write down the molar ratio. So I know that the mass of magnesium is 5 grams and the MR is 24.3. Now if I do mass divided by MR, I get moles, which is... And now I'm going to divide this answer by 2 to get the moles of oxygen, which is... And now I'm going to times this by the MR of oxygen so that I can work out the mass of oxygen that I would need for all of the magnesium to react. So for all of the magnesium to react with the oxygen, I'd need 3.292 grams of oxygen. However, I have 6 grams of oxygen. This means that I have more oxygen than what I need. Therefore, the oxygen is in excess and the magnesium is the limiting reactant. You can predict the weight of a product of a reaction. You can use the balanced equation to work out how many moles of a product you will form according to the ratio of the balanced equation. You can then use the formula mass equals moles times MR to work out the predicted weight of the product. Make sure for your molar ratio, use the moles of the limiting reactant, because once the limiting reactant runs out, the reaction stops and you stop making any more of the product, so the weight will stop changing. Okay, so here's the question that we just did. There's a little bit extra that I left out that we can now try finish off. Okay, so now that we know that the magnesium is the limiting reactant, we can use the molar ratio between magnesium and magnesium oxide to work out the mass of magnesium oxide we'd expect to make. So magnesium and magnesium oxide is a 1-to-1 molar ratio. So that means if I have 0.28 moles of magnesium, I have 0.28 moles of magnesium oxide. Now I just need to do moles times mR to get the mass of magnesium oxide, which is... So this is the mass of magnesium oxide we'd expect to make. Okay, here's another question for us to start from scratch. Pause the video, try it yourself, and play once you're done. Okay, so firstly, we need to find out which reactant is the limiting reactant. So to go about this, I'm going to do my table again. Alright, you can see that I've also included the product in the table. This is because titanium is going to be very useful in the working out later. So I'm just going to include it in the table to make things easier. Now to begin, I'm going to do the mass of titanium chloride divided by the mR. So I get... Now I need to times these moles by 4 to get the moles of sodium. Now I'm going to times it by the mR of sodium to work out the mass of sodium that I need. Right, so for all of the titanium chloride to react, we only need 48.45 grams of sodium. So this means we have more sodium than what we need. Therefore, the titanium chloride is the limiting reactant, so we use that for our molar ratio. So we have 0.5266 moles of titanium chloride. This means we're going to form 0.5266 moles of titanium. And this is because titanium chloride and titanium is a 1-to-1 molar ratio. Now I'm going to times the moles of titanium by its mR to get... So the maximum mass of titanium that we can produce is 25.2 grams.